Hi, this is Alex from devstories.eu. Pillow, the imaging library, episode 3 of 5. You feed a smartphone photo into your neural network, and its accuracy drops. The problem is not your weights or your architecture. If you simply squash a rectangular photo into a square tensor, you distort the features before the model even sees them. This episode covers geometry for models, resizing, cropping, and potting. You are preparing smartphone photos for a ResNet model that expects an exact 224 by 224 pixel input. Real-world photos come in all shapes. You have wide landscapes and tall portraits, but your model demands a perfect square. You have to bridge that gap without ruining the underlying data. The most common mistake is calling the standard resize method on the image and passing in the 224 by 224 dimensions. Resize is a blunt instrument. It forces the image into those exact dimensions and completely ignores the original aspect ratio. If the original image was a wide rectangle, it gets horizontally squashed. Circles become narrow ovals. The neural network learns from these distorted shapes, which degrades its performance in the real world. Resize does not intelligently fit an image, it just blindly warps it. To avoid distortion, you could manually crop the image. The standard crop method takes a 4-coordinate tuple defining the left, upper, right, and lower boundaries. You could calculate the center square of your image and crop out the rest. This preserves the aspect ratio and avoids squashing the features. However, it throws away data around the edges, and writing the math to calculate the exact center box for every incoming image size is tedious. Here is the key insight. Pillow has an image ops module designed specifically to solve this exact geometry problem. If you want to crop without doing the math, you use the fit method from image ops. You tell it the exact size you want, like 224 by 224. It calculates the aspect ratio of your requested size, scales the image down so the shortest side matches your target, and then automatically crops the excess from the center. You get a perfect square and zero distortion, with the subject usually kept right in the middle. What if you cannot afford to lose the edges of the image? If the subject is off-center, a center crop might cut it in half. In that case, you switch to the pad method from image ops. Pad scales the image down so the longest side fits your 224 pixel target. The shorter side will now be less than 224. To make up the difference, the pad method adds solid color borders to fill out the square. This is commonly known as letterboxing. The entire original image is preserved, the aspect ratio remains fully intact, and the model still gets its exact square. Whenever you change an image size with any of these methods, Pillow has to calculate the new pixels. For machine learning models where pixel-level detail matters, you want a high-quality resampling filter. When calling fit, pad, or resize, you can pass a resampling argument. A filter like bicubic is a strong standard choice here. It looks at the surrounding pixels to calculate smooth transitions, preserving the sharpness of the edges that your convolutional layers rely on. A neural network can easily learn to ignore block padding, but it cannot unsquash a distorted feature. That's all for this one. Thanks for listening and keep building.